But it's important that we take this point of symmetry and we do something with it. In this case, graph it. Okay? So, what am I graphing? I have a point of symmetry is at 411. I have a line of symmetry at x equals 4. So 1, 2, 3, 4. I know there's a line of symmetry right here. Right? And so I also know at 411, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, there's a point. And from here on out, I know that it goes like this. Because I know it's frowning, right? So, but where? And so here's the thing. A real nice way, there's two ways you can do this. One way, you can set it equal to 0. You can find the, do the quadratic formula and see where y is equal to 0, right? What does that do? If y equals 0, if y equals negative x squared plus 8x minus 7, right? Yeah. Then 0 equals negative x squared plus 8x equals minus 7. If we set y equal to 0, what happens? It's going to give us 2 points somewhere on the x-axis that are symmetrical to this point. So that's one way of doing it. Okay? Another way of doing it is setting x equal to 0. I like to set x equal to 0. Okay? Your book likes you to do the quadratic formula. Why? Because that's what we've been working on, right? But I like to go, well, it's just easier to make x 0, right? Because what if I make x 0? Y equals negative x squared plus 8x minus 7. And if x is 0, then y equals negative 7. Right? If x is 0, y equals negative 7, because 0 squared is 0, and 0 times 8 is 0. So it's always, with the quadratic, it's always just the last number, what y equals, when I put x in for 0. So what does that mean? X is 0, and y is negative 7. What does that mean? Well, that means that at 0, y is what? 1, 2, 3, 4, 5, 6, 7. Okay, that's what it means. But wait a minute. Wait a minute. Beyond that, well, if I know they're symmetrical, how far away am I from the line of symmetry?
4.
4. So how far over here is it going to be before I'm back at negative 7?
8.
8. So I should be 1, 2, 3, 4, 5. Wait. 4, 5, 6, 7, 8. So right here should be my other point, right? Should be. I didn't prove it yet. So how do you know you're right? Check it. Plug it in. At what? At x equals 8. And see if you're right. Y would equal negative 8 squared plus 8 times 8. Minus 7. Anything look familiar here? 64, so negative 64 plus 64 minus 7. 0 minus 7. Y equals minus 7, whereas x equals 8. So you have that point. Boom. You proved it. This is your graph. And it's that simple. It really is that simple. Use your derivative. Okay? Use the derivative to find your point of symmetry. Once you have your point of symmetry, just plug 0 in for x. Don't worry about using the quadratic formula again. That's a lot of number crunching that you don't have to do. Use your brain. Plug in the x, plug in the 0 for x, boom, you get a number. Cool. See where that number is in comparison to where your line of symmetry is. Okay? Add that to your line of symmetry. It could be 3, your line of symmetry could be at 3.5, right? So you're going to have 2 3.5, right? Or in other words, 6, 7. Yeah. It could be 3 square roots of 2, right? Well, you're going to have 2 times 3 square roots of 2, which is 6 square roots of 2. Right? So even if you have hard numbers of a line of symmetry being square roots of 2 or anything like that, it's still easy to find the other part because it's just 2 times it. Okay? So believe me, I know the book does it a certain way, but there really is a method to my madness, and usually it's because it's easier. A true mathematician looks for the easy way out. Okay? We try to make things easier for us and everybody else. That's all I got.